This is section 8.4, part B, vectors in three-dimensional space. Just like we had in 2 dimensions, in 3 dimensions you still have vector operations in space. You can still do vector addition, so you just add the components, they're in the same location. You have vector subtraction, so you can subtract the components that are in the same location. And you have scalar multiplication, which just means you take that scalar value and distribute it to each coordinate. So for this one, we have y times vector y, 4 times vector y plus 2 times vector z. If we write this out, vector y is 3, negative 6, and 2. Vector z is negative 2, 0, and 5. The first thing we're going to do is distribute that scalar. So this will give us 12, negative 24, and 8. If we distribute that 2, we'll have negative 4, 0, and 10. And when you do the addition, you just add the components that are in the same location, and you should end up with 8, negative 24, and 18. If we do the same thing in the second example, we have 2 times vector w minus vector z, and then plus 3 times vector y. When we distribute, this is going to give us negative 2, 8, and negative 8. Let's go ahead and distribute that negative, so it's just addition after this. Negative times negative gives us positive. We add these components together. Negative 2 plus 2 is 0, plus 9 gives us 9. 8 plus 0 is 8, plus negative 18 gives us negative 10. And negative 8 plus negative 10 is negative 18, plus 6 gives us negative 12. After liftoff, a model rocket is headed due north and climbing at an angle of 75 degrees relative to the horizontal at 20 miles per hour. If the wind blows from the northwest at 5 miles per hour, find a vector for the resultant velocity of the rocket relative to the point of liftoff. So we have to think we're in 3 dimensions now. You're either going to have an x and a y, an x and a z, or a y and a z, but you will not have all 3 at the same time when we're building our initial vector. Your resultant vector can have all 3 components. So our airplane that is taking off, or our model rocket that's taking off, think of your x and y as being on the ground. Your z is going up and down. East and west would be your x coordinate, north and south would be your y coordinate, and then if it goes up in the air, that is your z. So our rocket is lifting off and heading due north. North would be your y. So if my y, it's going in the direction of y, 75 degrees up. So for our first vector, we do not have an x coordinate. To find the y coordinate, you take the magnitude, and it tells us it's traveling 200 miles per hour. You take the magnitude times the cosine of your angle. To find the second coordinate, or the second component of this, you do the magnitude times the sine of the angle. Now before, cosine always went with the x and sine always went with the y. Now cosine goes with whatever comes first. Sine comes with whatever comes second. So this could be an x and a y, it could be an x and a z, or it could be a y and a z. It's just going to depend on the context of the problem. So our vector v is going to be 0, 51.76, and 193.19. Now to find vector w, we're talking about the wind. If we look at a coordinate plane, we have north, south, east, and west. It says the wind is blowing from the northwest. Since it says northwest and it doesn't give you direction, you have to assume it's exactly halfway between north and west. So that means this is 45-degree angle here, and this is a 45-degree angle here. Because our vector is going down to the left, the first thing we need to do is find our measures. Now, east and west, north and south, this means I'm talking about my x and y values. So for the wind, I'm going to have an x and y value. We know that the wind is blowing at 5 miles per hour. So it's 5 times the cosine of 45. It's going down. It's going towards the south because it's coming from the north. So this is going to be a negative 5 times the sine of 45. And then we're going to have 0. So it's a positive 5 because it's going towards the right, because it's going towards the east. But it's a negative 5 because it's going down to the south, because it is coming from the northwest. So this means our wind vector is going to have the components of 3.54, negative 3.54, and 0. We need to find the vector of the resultant of this. Remember to find the resultant. You just take your two vectors and you add them together. So this is going to be 0 plus 3.54, 51.76 minus 3.54, and 193.19 plus 0. So our resultant vector will have the components of 3.54, 48.22, and 193.19.